Okay, so we're going to look today at 6.4, the second half of graphing sine cosine functions. We're looking at vertical and phase shifts. Last time we looked at both amplitude and period. So this time we're looking at a little more here this time. All right. All right, so the vertical shift, let's define that. Number added or subtracted to the function, same as before. That's what I'm referring to. Quadratic functions, square root functions, absolute value functions, same deal. If a plus or minus something on the cosine or sine function, you're going to move it up or down. Phase shift. Trig way of saying horizontal shift. So it's the same as before. Once again, if you replace x in the square root function, or in the absolute value function, or the x squared function with x minus c, it would shift c units right, and with x plus c, it would shift c units left. So just a little something to remember here. Remember to factor. If you have something of the form omega x plus phi, that's phi, by the way. Showing off our Greek letters again here. This is a new one, phi. Omega, you've been introduced to. So if we have something of the form omega x plus phi, we factor out omega, and we're left with x plus phi over omega. If you distribute that out, you'll see that it's equivalent. So if you see something, the argument of a cosine or sine function as omega x plus phi in that form, be sure to factor out the coefficient of the x term first before you go and find your period and phase shift. All right? So let's look at our step process here. On your notes, you should have for graphs of y equals a sine of bx plus, I have c on there for you. Yeah, graphs of, well, I have lowercase a. I switched to lowercase a sine of b. B is factored out, x minus c plus d, where we call a, lowercase a, we're going to call that the amplitude. I think I called it, had an uppercase a on the notes before, but lowercase a is our amplitude, lowercase b is related to our, is not our period, but is related to our period with the expression 2 pi over b, or period equals 2 pi over b. So b would be equal to 2 pi over the period. And c is our horizontal shift or phase shift, and d is our vertical shift. So we're going to determine the amplitude, period, phase shift, and vertical shift. And the phase shift will be the starting point of a cycle. So we're going to identify that first and shift it first, get our starting point, and then go from there through our increments that we find. So add the increment length to the starting point 4 times to arrive at the end of the period. And then the third step will be plot the key points. So I'm talking about the intercepts. These intercepts, though, won't be x-intercepts this time. They could possibly be intercepts of what's called the midline. It's kind of like the new x-axis after I've shifted up or down. And then also the high and low points. So here we go. Take the function y equals negative 4 sine 3x minus pi over 6 plus 1. So we're going to do our remember to factor right off the bat here. So we have y equals negative 4 sine. We're going to factor out a 3. 3 times what is x? That'll be x. 3 times what will give me pi over 6. So when I factor out a 3 here, I should end up with a pi over 18. Just double check that here. And then plus 1. So take 3, distribute it out, you get 3x minus 3 pi over 18, which is pi over 6. You're just asking yourself, 3 times what equals pi over 6? 3 times, call it y, equals pi over 6. When I solve for y by dividing each side by 3, I get pi over 18. So that's what's left over right here. All right, now we're ready to identify our amplitude. Same as before. Amplitude is the a in front. Amplitude is equal to 4. We take the absolute value of that negative 4. We get 4. The period is equal to 2 pi divided by b. In this case, b is the number out in front of the parentheses there. So 2 pi over 3 is our period. The phase shift, we're going to abbreviate that PS for phase shift or horizontal shift, is right here. It is right here. We've got, it's of the form x minus c. If it's of the form x minus c, the horizontal shift is positive pi over 18. So I'm shifting positive pi over 18 units to the right. And the vertical shift is equal to 1. And so we're just identifying each of those key points of our graph. We're not going to graph it yet. We're just stating the amplitude, period, phase shift, and vertical shift. So we'll do that for the next one as well here. Once again, we're going to factor out. This is written in a little different order here. We have the vertical shift out in front here. We're going to factor out a 1/5. So we have x plus, so we can say 1/5 times what? Y will give me pi. And if you solve that for y, you get 5 pi. 5 pi here. And so distributing the 1/5, just to double check it, that's x over 5 plus 5 pi divided by 5 is pi. You could even move this over on the other end if you want to, if I'd seen that ahead of time. So the amplitude is equal to 3. It's the absolute value of -3. The period is equal to 2 pi divided by b, which is right here, 1/5. Which is 2 pi times 5 over 1, or 10 pi. My phase shift now is easy to see. In this case, the phase shift is -5 pi. You can see in here we have x plus 5 pi, so it's what would make that equal to 0. Would be my phase shift, so -5 pi would make that expression x plus 5 pi equal to 0. And then the vertical shift, we see it out front here. I circled it. Vertical shift is 3 units down, so -3. So, big thing there is remember to factor out that coefficient of x before you start identifying all those pieces. Alright, we're going to, number 2 here, write a sine function that has the given characteristics. So we're given some characteristics, we're going to write a sine function that works. I have to state sine function because you could find a cosine function of those same characteristics. So we have y equals, it says an amplitude of 2, so we're going to put 2 out in front. And then sine, we have a period of pi, so I've got 2 pi over b has to equal pi. If I cross multiply or swap these two here and here, then I have 2 pi over pi equals b, and so b equals 2. So I have a 2 out in front. And then I have a phase shift of 1/2. So a phase shift of 1/2 would mean, in parentheses, I have x minus 1/2. So phase shift of positive 1/2 will give me x minus 1/2 in parentheses. That's it. So I've got my amplitude of 2. I use the period, plug it in to that expression 2 pi over b equals period, solve for b, and the phase shift is what you see in parentheses there. All right, next one, we've got another sine function here. We have y equals, it's got an amplitude of 3, so we're going to place 3 out in front. And I'm going to use my expression 2 pi over b equals the period of 1.5, or let's write it as 3 over 2. Cross multiply here, 4 pi equals 3b. So b equals 4 pi over 3. So that's my b. So I'm going to go 3 sine 4 pi over 3. And then in parentheses I have, move all this stuff. So in parentheses I've got a phase shift of -3, so I'm going to write x plus 3 here. The phase shift, and a vertical shift of plus 5. Notice the plus 5 comes after the whole sine function. So that's one way to write it. I prefer that method because I can then quickly and easily graph it from there. You might see in the textbook or in real life problems that they will distribute the 4 pi over 3. So another solution, another way to write the solution might be 3 sine of 4 pi over 3x plus 4 pi, all in parentheses, plus 5. That's another way you might see it written. So either way, it would be fine. It depends on if we're going to graph it or not. Depends on what the, it could come in either form. So you should be able to go back and forth between the two. All right, let's get into graphing a cycle of one of these functions that has all these different aspects: an amplitude other than 1, a period other than 2 pi, a phase shift, and a vertical shift. So let's try this next one here. All right, so we're going to go through our step process. Determine the amplitude, period, phase shift, and vertical shift. So all that quick, easy to do. Amplitude is 3. The period is equal to, well, we probably should rewrite this as 3 cosine of factor out of 3. I'm left with x minus, question once again is 3 times what equals pi? It's pi over 3. So 3 minus pi over 3, and then plus 1. So there's my new equation here. So period is equal to 2 pi over b. In this case, b is 3. I've got a phase shift equal to pi over 3. That's positive pi over 3. And a vertical shift equal to 1. So when I go to graph this, draw my XY grid here, I'm going to end up having a new, what we call midline for this. And I like to draw that first, and then I'll go ahead and do the phase shift. So my midline here, it helps if I know the amplitude is 3, the vertical shift is 1. So normally I would be right on the x-axis. I'm going to end up shifting up 1 unit. So my new midline, vertical shift, will be up 1. So from there, I got to go up 3 units to account for the amplitude. So 1, 2, 3, that will bring me up to 4. There's 3, there's 2. My midline's at 1. 1, 2, 3, so I'm down to -2. So my range will go from -2 to 4. My midline is at y equals 1. My phase shift is pi over 3. Now, I'm going to go ahead and find my increment here. So let's go ahead and find the increment. It says add the increment length to the starting point 4 times. So let's go ahead and find the increment, and then we'll add it to this pi over 3. So we're going to start at pi over 3 on here, and then go, we can even put the pi over 3 in here, but I'm going to find my increment first here. So my increment, abbreviated INC, is equal to my period here, 2 pi over 3 divided by 4. And so that equals 2 pi over 3 times 1 over 4. So we've got pi over 6 as my increment. So I am going to start at pi over 3 right here. And I'm going to space this 1, 2, 3, 4. So 1, 2, 3, 4. My increment is pi over 6. So what's happening here is I'm going to count by pi over 6s, but starting this time at pi over 3, not at 0. So it might even help to think of pi over 3 in terms of 6s. Pi over 3, we know, I multiply by 2 over 2 equals 2 pi over 6. So really, pi over 3 is 2 pi over 6. Do that and then go back and reduce or whatever, just leave it in unreduced form here. So if I go, the next one would be 3 pi over 6, also known as pi over 2, 4 pi over 6, also known as 2 pi over 3, 5 pi over 6, and 6 pi over 6, which is also pi. And so my period, my cycle is going to go from pi over 3 to pi. I'm starting at pi over 3. This is a cosine function. It's going to start pi, so it's going to start up at 4. If you're not sure what to do, just plug in pi over 3 right here for x. It's not too bad to do. 3 times pi over 3 would be pi. Pi minus pi is 0. Cosine of 0 is 1. 3 times 1 is 3, and 3 plus 1 is 4. So by plugging in pi over 3 for x, I see that I end up at 4. So there's my starting point. I just verified it here. And then we know, it doesn't matter where the x-axis is, this time it happens to be y equals 1 is our x-axis, that the next increment will bring me to that axis. And then the next increment will bottom out. So I'm going to bottom out at 4 pi over 6 comma -2. And then at 5 pi over 6, I'll be back on the midline again. This once again is called the midline. I'll label that. And then complete the cycle up at 6 pi over 6, or pi, comma, 4. There's one cycle of that function with everything in it, all 4 pieces. All right, let's do another one here. Do a sine curve. This one is reflected, so note that negative out in front is going to reflect it. Let's go ahead and rewrite this right away. We've got negative sine. We're going to factor out a 2. It's 2 times what? Equals pi over 2. Y equals pi over 4. So we've got, when I factor out the 2, it's x plus pi over 4. You can check it by distributing the 2 if you'd like. Alright, so once again, amplitude is equal to 1, the absolute value of negative 1 there. Period is equal to 2 pi over 2, which is pi. My phase shift is equal to negative pi over 4. And my vertical shift is equal to 0. There's no vertical shift here. My increment is going to be the period pi divided by 4. That's good to know. Let's go ahead and draw our graph here. Our midline is right there on the x-axis. Y-axis is over here. My amplitude just goes up to 1, negative 1. And my phase shift is negative pi over 4. So what I'm going to do here is start over here at negative pi over 4. I'm going to start. And then my increment goes up by pi over 4. So counting by pi over 4 is negative pi over 4 plus pi over 4 would put me at 0. And then pi over 4. And then 2 pi over 4. So I've gone 1, 2, 3. Got to go one more. So I go up to 3 pi over 4. So my cycle will end at 3 pi over 4. Now, if you'd like to, you can plug in a value here. You could plug in negative pi over 4 if you'd like, right here. Don't remember that sine starts on the midline or on the axis. Negative pi over 4 plus pi over 4 is 0. 2 times 0 is 0. Negative sine of 0 will be 0. It's going to start right here. Then from there it's going to go up, top out at 0, 1. Hit the axis again at pi over 4. Bottom out at 2 pi over 4 or pi over 2. And then complete a cycle at 3 pi over 4. So that's a graph of y equals negative sine 2x plus pi over 2. Alright, going the other direction. We'll wrap it up with this. It says find a sine and cosine equation that matches the graph. So the amplitude is not going to change for either one. We can see from here to here, we've got a midline. It looks like the midline is right on the x-axis, so there won't be any vertical shift. The amplitude is equal to 3.5. Amplitude is 3.5, so in each case it'll be 3.5 out in front of the function. Let's look for our period here, and then from that we can get our b. So if I'm using the sine function, I might start right here and go to here. Or using a cosine function, I might start here and go to here. Either way, I'm going to have the same period. So it looks like we're counting by pi over 3s. There's pi over 3. 2 pi over 3 would be right here. And then pi. So if I want to go just looking at this for my cosine function, which is the same period as my sine function, looks like it goes from 0 to 2 pi over 3. So my period is equal to 2 pi over 3, which means b, we have the relationship period equals 2 pi over b. So that would mean my b is equal to, let's write it out here. So we got 2 pi over 3 equals 2. And so b equals 3. You can see that right here. B equals 3. So we have b, we have a, the amplitude. There is no vertical shift. There's definitely a phase shift for the sine function. The sine function has a phase shift that's halfway in between 0 and pi over 3. So halfway in between 0 and pi over 3. Let's go ahead and write that down. Now by 2, we're just finding the average. So that's pi over 3 over 2, which is pi over 6. So that's my phase shift for the sine function. Let's go ahead and do the cosine function first. Cosine starts high up there at 0, 3.5. The amplitude is 3.5. Cosine of b we said was 3. And we don't have any phase shift, so it's just 3x. So there's my cosine function. We'll box that. Y equals 3.5. The sine function, it looks like the sine function, if I start right here, let's put green here. Go through a cycle here. It looks like it's been reflected. It's heading downward first. So we're going to have a negative out in front of that 3.5, sine function here. Out in front, our b is still 3. We do have a phase shift here. It's x. It's been shifted, you'll see right here, pi over 6 units to the right. So we're going to have a minus pi over 6. No vertical shift. So that is my sine function.